When you're actually solving radical equations, the first thing you need to do is isolate that radical. So get anything around it away so that on one side of the equal sign you just have your square root or cubed root or whatever it is. The next thing you're going to do is get rid of that radical by squaring. However, if it's a cubed root, you're going to cube, and a fourth root, you're going to fourth, etc. And then you're going to solve, and then you're going to lastly check for extraneous solutions. So that's checking for those answers that you have that maybe when you put them back in, they actually don't work and they don't make sense. So that would be an extraneous solution. So this question is, the square root of x plus 3 is equal to 4. So our first step is to isolate the radical. So I take a look at my radical and I see if there's anything way on the right of it or anything multiplied or added on the outside of it, and there isn't, so that means that it is isolated. Once it's isolated on one side, then I can square this entire side and square this entire side. Because it's isolated, this whole thing is squared and square rooted, which cancels each other out. So I'm left with x plus 3 equals 4 squared, which is 16. Now I'm free to solve, so I'm going to subtract 3 on both sides, and I'm going to get that x equals 16 minus 3, which is 13. Now my last step is just to check. If I plug my answer 13 into here, back to my original, I'd get that the square root of 13 plus 3, in other words, the square root of 16 equals 4. Which is true, the square root of 16 does equal 4, so that makes sense. There's no extraneous roots there. This is the square root of x plus 1 minus 3 equals 2. So again, first step is to isolate the radical, and I see that this negative 3 is sitting here on the same side as my radical is, so I want to get rid of that 3 first. So I'm going to add 3 on both sides, and I'll get the square root of x plus 1 equals 2 plus 3, which is 5. Now my radical is on its own over here, so I'm free to square. Square both sides. Again, squaring and square rooting are opposites, so they cancel out. And I get that x plus 1 equals 25. Now I can just solve for x, so I just need to take away 1 from both sides, and I get that x equals 24. And a quick check with 24 in here gives me the square root of 24 plus 1, or the square root of 25, which is 5, minus 3 equals 2, which is true. So that is my answer for that one. Here I see that I have a 2 on the outside of the radical, so I need to deal with that first. So it's multiplied by 2, so I'm always going to do the opposite to get rid of things. So I'm going to divide by 2 on both sides. That will get rid of that. So now I have the square root of 2x plus 1 equals 4, because 8 divided by 2 is 4. Squaring both sides, I end up with 2x plus 1 equals 16, because again, the squared and square root just cancel each other out. I'm going to get rid of that 1, get rid of that 1, so I end up with 2x equals 15, and I can divide by 2 and divide by 2, and I'll get that x equals 15 over 2. If it's not going to come out to a whole number, you can definitely just leave it as a fraction, as long as that fraction is can't be reduced anymore. If I were to go back in and check this, I'd get 15 divided by 2 times 2 is just 15, plus 1 is 16, the square root of 16 is 4, times 2 equals 8. So that all seems to check out. Here again, I have a radical, but I have something on the outside. Sometimes we forget that this negative here means the same thing as multiplying this by negative 1. So this is actually the square root of 3x plus 2 times negative 1. So again, the opposite of that is to divide by negative 1, which will get rid of that, and then divide by negative 1 on this side. So now I have the square root of 3x plus 2 equals negative 5. I'm going to square both sides. Make sure when you square with a negative number, if you're squaring that whole side, it's the whole thing squared. So it's not just 5 squared and then a negative, but it's negative 5 times negative 5, which is positive 25. And then I'm left with 3x plus 2 because my squared and squared root canceled out. I can take away 2 from both sides. I'll get 3x equals 23. divide by 3, divide by 3, x equals 23 over 3. And if I plug that back in quickly, I'll get that 23 divided by 3 times 3. Well, those 3's will cancel out. And I'll just get 23 plus 2, which is 25. Square root of 25 is just 5 or negative 5. So remember that when we take the square root of a number, it could be the positive version or the negative version. So that is our negative version answer. Here I have radicals on both sides of my equation, but because there's nothing extra here and nothing extra here, I can actually square both sides and it will clean up for me quite nicely, because squaring both of the square roots in both cases is going to get rid of my square root. So now I have just x plus 1 equals 2x minus 3. And I need to make sure, remember when you're solving, that all of your variables get on one side. So my issue here is I have variables on both sides. So I could subtract my 2x from this side and subtract my 2x from this side, which leaves me with negative x plus 1 equals negative 3. And if I just subtract 1 and subtract 1, I end up with negative x equals negative 3 minus 1, which is negative 4. Divide by negative 1, divide by negative 1, I get x equals 4. And then one last check, if I were to put 4 into both of these, would it make sense? So if I put 4 into here, I'd get the square root of 5. And if I put 4 into here, I'd get the square root of 2 times 4, which is 8, minus 3, which is also 5. So on both sides, I'd get the square root of 5, which makes sense, that the square root of 5 equals the square root of 5.